at the start of Unit 8, and we're kind of going back and reviewing a little bit. We'll have a little bit more complicated than normal problems, but it's actually a whole lot of review. And so let's start off with power rules. If we have x cubed plus x squared, remember that's really x times x times x times x times x, so it would be x to the 5th, which the power rules really state that you are doing x to the 3 plus 2 power, because if the bases are the same and you're multiplying, you add the exponents. Now, power to a power is really like x to the 4th times 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 x to the 4th, which would be like 4 plus 4 plus 4 plus 4 plus 4, which would be the same thing as x to the 4 times 5 power, so x to the 20th. So we've got multiplying just general polynomials. We've got a couple different examples for you. This first one, we've got one term on the outside and we got 4 terms on the inside. So we need to distribute the whole term to everything, which means I now have 2x cubed times 4x cubed, which would be 8x to the 6th because we add the exponents, minus 2x squared times 2x cubed would be 4x to the 5th. 2x cubed times x would be plus 2x to the 4th. And then 2x cubed times 3 would be plus 6x cubed. None of those have the same variable to the same power, so we leave it. Remember, standard form, highest variable, or variable to the highest power, and then you decrease on down. Looking at this next one, we could go x times x cubed times 3x squared times negative 2x times 4, and then negative 3 times x cubed times 3x squared times negative 2x times 4. A lot of you tend to get lost when we do that. So instead, I would strongly recommend you use a lattice method. That means I'm going to take x cubed plus 3x squared minus 2x plus 4 along the top and x minus 3 along the side, and I create a box. And everywhere there's a symbol, I draw a line. So I have 4 terms up top, 2 terms on the side, so that's going to be 8 terms total. And then I multiply it out. So x cubed times x is x to the 4th. Then we have x times 3x squared, which is 3x to the 3rd. And then we have x times negative 2x, so negative 2x squared. And then x times 4, which is 4x. And then I take and distribute that negative 3 through, which is basically what I'm doing up top here. So we have negative 3x cubed, negative 9x squared, positive 6x minus 12 as I distribute that through. And then the nice part about going this route is that all of my like terms will fall in diagonals. And then the things that are non-like terms will be all by themselves on the corners. So, that being said, when I multiply this all out, I got x to the 4th all by itself. I have negative 3x cubed and positive 3x cubed, which boom, cancel. Negative 9x squared plus 2x squared, which is negative 7x squared. 6x and 4x, which is 10x, and then I have the lonely minus 12. And then I've got my answer without having to worry about organization and losing things. Now, we got one more example. A plus b, the quantity cubed. A lot of you guys want to just say a cubed plus b cubed and be done with it. Unfortunately, that's not how it works, because remember, an exponent means that what's inside is multiplied out that many times. So we have a plus b times a plus b times a plus b 3 times. When you do this, you group. So first, we FOIL the first 2. So a plus b times a plus b, we got a times a, which is a squared, times A times B, plus A times B, which is AB, plus B times A, which yes, BA, but it's also AB because we put them in alphabetical order, plus B times B, which is B squared. We still have the A plus B out here. But then we look and we combine like terms. We have A plus B, so we really have A squared plus 2AB, because we have two of them, plus B squared times A plus B. And then once again, we're in that situation where we could repeatedly distribute the A and then repeatedly distribute the B. And if that works for you, great, wonderful. If that doesn't work for you, then we can throw it into a lattice. So we put the A plus B down on the side and the A squared plus 2AB plus B squared across the top. And we make our box. We draw our lines. And then we multiply. A times A squared is going to be A cubed. 2AB times A is 2A squared B. I know that's confusing for you. And then A times B squared is AB squared. A squared times B is A squared B. 2AB times B is 2AB squared. And then B squared times B is B cubed. So then we look nicely down our diagonals. We've got our matching terms, and non-matching terms are in the corners. So then we can go ahead and write our final answer, which ends up being A cubed. We have 2A squared B and A squared B, which, remember there's like a 1 here, so that's plus 3A squared B. And then we've got 2AB squared and an AB squared, which is plus 3AB squared plus B cubed. Now this gets confusing because you got all these A squared B's and AB squareds. But remember, the A is first alphabetically, so it goes 3, 2, 1, 0. And the B's are seconds. We go 0, 1, 2, 3. We go in opposite order. And you can't combine A squared B and AB squared because they are not the same, because you have A squared and A, B, and B squared. So that is your final answer. So now, I want you to practice. I got two little less problems that are a little less confusing. We got 2x minus y times x squared minus 4x plus 7. Yes, I threw that y in there so we can see if you can write it in standard form, and we'll work with that. And x plus 3, the quantity cubed. Work on that, and as always, bring your questions with you.